Hey everybody, this is Mr. Beckstrom, and today I'm going to look at an example from section 3.1. This is a question that's similar to number 8 and one that's pretty similar to the other two questions that we were looking at in this section as well. It says use the following definition of the slope of the tangent line at x is equal to a to find the slope of the tangent line to the graph of f at the point P. They give us a formula to define the actual slope of that tangent line. M is the slope, and the subscript there says that that's for the tangent line there. And they give that similar formula to the one we've been using. We have the f of a plus h minus the f of a all over h. Since x is equal to a, you'll often see that formula with an x there as well. Here's our point, P. So the 1 is our x value, just x is equal to a, and our a value. So that's the one that we're going to replace with the a value, and this is our equation here that we're going to use in order to find the slope. So all right, so let's go ahead and get started. This is kind of a lengthy problem, and we have to possibly brush up on some algebra skills in order to solve this. So the first thing I want to do is I just want to replace the a with my x value there. So I'm going to do it. I'm just going to leave off the m subtangent there. So we have the limit. And one other thing I'm going to go ahead and do is, just to save a little bit of time here, I'm going to put a little quotation marks for the limit of h is equal, or h approaches 0. Just so I don't have to write that every time. So little quotation marks, because it's going to be attached to everything that we do. So we're going to have f of, instead of a, we're going to do 1 plus h. And remember, we can either do this step in the beginning if we're only going to find the slope for one point on this curve, or we can leave it as a if we want to generate an equation that'll give us the slope for any x value that we decide to put into that slope. All right, and then we're going to have minus f of a, so minus f of 1 all over h. All right, and then we're going to go down, so the limit is h approaches 0 of, and then I am going to plug this in. So this says go up to the f equation, write it, and instead of x, we're going to put in h plus 1. So this is going to be 1 over 3 plus 2 times, and then we're going to have, instead of x, we're going to have 1 plus h minus, and since I'm subtracting there, I'm going to go ahead and put the second thing in parentheses so I remember to distribute that minus sign there. So minus just f of 1, that just means original equation with a 1 instead of an x. So that's going to be minus 1 over 3 plus 2 times 1. 3 plus 2 times 1. Okay, all over h. All right, so we had the limit as h approaches 0 of this big thing. So let's go ahead and use some algebra to clean this up a little bit, combine the top. Remember, our goal with just about all of these is to somehow get rid of that h out of the bottom, because when we plug that 0 in there, we always start off with, we're going to get 0 on the bottom. And then if you put a 0 in there for the h here, you're just going to get f of a minus f of a, which is going to be 0. So we get that indeterminate form, which means we have to keep going. So that's kind of the process of this. All right, so then we're going to get the limit as h approaches 0 of, this becomes 1 over, so this is going to be, if we distribute that, that's going to be 2 plus 2h. So 2 plus 3 is 5. And 2h, so that's 5 plus 2h. And then this is going to be minus 1 over 5. 1 over 5, like this. All over h. All right. Minus 1/5. If you want to keep putting a parentheses around there, just to make sure that we distribute that, because it's going to be messy if we don't. All right. Now, in order to find a common denominator, remember when we're dealing with denominators that have different variables, usually what we just do is we multiply them together to find that common denominator. So the common denominator would be, I'll kind of write it up here, common denominator is just going to be the first denominator, 5 plus 2h times the second denominator times 5. All right, so in order to get the common denominator for the first fraction here, I'm just going to multiply that by 5 over 5 in order to get the common denominator here. And for the second one, I'm just going to multiply by the 5 plus 2h plus 2h all over 5 plus 2h. Hopefully you've seen this before. It should have shown up in both pre-calculus algebra and pre-calculus trig quite a bit. So now we're going to go to the next step and limit as h approaches 0. Now that we have this common denominator, let's go ahead and kind of clean that up. So this first part is just going to be 5 all over. If we distribute that 5 here, we're going to get 25. 5 times. You can just do it like this if you want to. Remember to distribute that, right? 25 times 10h, or plus 10h, excuse me, plus 10h. Then we have a minus, and on the top, I'm going to have the 5 plus 2h. 5 plus 2h. And on the bottom, I am going to have the 25, and then the plus 10h. 10h. Now we should have the common denominator, which we do. So let's go ahead, and this is going to all be over h. So now let's go ahead, bring it up over here. So once again, quotation marks for the limit as h approaches 0. I'm going to go ahead and do this now. So this is going to be on the top. We're going to bring the tops together. So 5 minus 5. And then we have to distribute that minus sign. So a minus times a plus is a minus. So that's minus 2h. All over that common denominator. This is in the numerator of the big fraction here. All over 25 plus 10h. 10h. All over, or old quotient line, all over h. Now notice 5 minus 5 is just 0, so we're going to cross that out. And now I'm going to go ahead, there's not much else I can do at the top. So remember, when we're dividing with fractions, we can multiply by the reciprocal of the denominator. And the reciprocal of h is just 1 over h, so that's what I'm going to do next. So the limit as h approaches 0, I'm just going to put this, so minus 2h all over 25 plus 10h plus 10h. And instead of dividing by h, I'm going to multiply by 1 over h. This h will cancel out with this h. And that should be enough to go ahead and get us a working limit. So let me go ahead and write it in this time, just so we can try to evaluate it at this point and get something other than the indeterminate 0 over 0 form. So this is the limit as h approaches 0. Remember, you keep this limit throughout the whole thing until we're able to apply it and get a non-indeterminate form, which is something that's not 0 over 0. So now, if I try to apply that 0, plug it in where the h is, this is the only place I'm going to get it. So this is going to be equal to, there's just a 1 on the top, and then, oops, I'm sorry, negative 2 on the top. negative 2 on the top. This is a negative 2 right there. So negative 2, there's no more h's on the top, all over, and you put a 0 in there, it zeroes out this term right here, so you're just left with a 25 on the bottom. So negative 2 over 25. So that is the slope of the tangent line at the point P, 1, 1/5. All right, and then the last part of this, it says, well, part B, I don't think I copied it over, but it says to find the equation of the tangent line. And it gives the 4 equations in slope-intercept form. So I'll get you started, but I'd like you to try to work that one out. So use the point slope to start because we have the point and we have the slope. So the point slope says y minus y1 is equal to m times x minus x1. So the process here is your slope here, so you plug that in there. The 1 is your x1, and the y1 is the 1/5. So you plug those in there, and then you end up solving for y. All right, if you have any other questions, let me know, and I hope you have a great rest to your week. Thank you.